In this video, we're going to focus on the AC method of factoring. It's considered like opposite operations for FOIL factoring. So think of foiling in reverse. So like in this case, if we were to FOIL p plus 5 and p minus 4, well, p times p is p squared, p times negative 4 is negative 4p, 5 times p is 5p, and 5 times negative 4 is negative 20. Negative 4p and 5p combine to make just 1p. Essentially what the AC method does is take from here, this trinomial, break it into this piece right here, the 4 terms, and then from here you'd be factoring by grouping. Group these two, and you would factor by grouping. So, how that looks. Anytime you have a trinomial in the form a times x squared plus b times x plus c, and the only time this can be different is if you had a cy squared and a bxy. This will work as well, but normally we'll be looking for ax squared plus bx plus c. In this case, you'll take a times c, and we call that ac. So a is just the number out front of x squared. It does not include x squared. It's just this number. So if it was 3x squared, we would just call a 3. This number c at the end, so like plus 8, c would be 8. The only time again that this is different is if it's a cy squared, you use this whole thing here. You'd use cy squared, and that would become this piece, the ac at the end. So once you have your AC, you're finding the factors of AC that would add up to B. And we'll call these factors D and E. What I mean by that is, if this was 1 and this was 8, AC would be 8. If B was 6, we would need factors of 8 that add up to 6. That'd be 2 and 4. That would help us break this 6x into 2x plus 4x. We're rewriting the expression as 4 different pieces all separated out, and then we would factor by grouping. So just like over here where this was 1p and 1 came from negative 4 plus 5, those two added up to 1, and those two, negative 4 and positive 5, also multiplied to this negative 20. Okay, so that's where everything comes from, and we'll see how it works as we work through a couple of these examples. So for our first example, again, we always check for the greatest common factor first. This one does not have a greatest common factor, so we jump right into defining our a value is 1, because there's just a 1t squared. Our b value is negative 10, because there's a negative 10 here. And our c value is 21, right here. That means a times c, 1 times 21, is 21. Now we're asking what are the factors of 21 that would add up to negative 10. Now, factors of 21 are 1 and 21, or 3 and 7. These are the only sets of numbers that will multiply to make 21. Because we're looking for a negative number, we want a negative 10, and this number here was positive, that means either these are both positive, because positive times positive is positive, or they're both negative, because negative times negative would make a positive. Because this is positive and we need these, or negative, and we need these to add up to a negative, these have to be negative. So we're looking for the set of these factors that would add up to negative 10. In this case, it's going to be negative 3 and negative 7. So those are the numbers we use to break this expression up into 4 terms. So it's now t squared minus 3t minus 7t plus 21. So this became 4 different terms, and now we can factor it by grouping. Here is our first group, and here is our second group. In the first group, what can we take out of both of those pieces? Well, we can take t out, leaving t minus 3. In the second group, what can we take out of both of those? We can take negative 7 out, which leaves t and minus 3. Because this times this is this times this makes this. Same thing over here. Now, we have t minus 3 in both cases. One case times t, one case times negative 7. So our two factors are t minus 3 and t minus 7. This is our factored solution then. Again, if you were to FOIL this all out, this would add back up to this expression. We're going to move away from the AC for 1 second here. We're going to go back to reminding ourselves that we need to check for the greatest common factor. On this one, because there are two terms, we can't use the AC method, but we know we need to check for greatest common factor first. In this case, that's going to be 4. We can take 4 out of both of these and leave 4m squared minus 25 with this 4 on the outside still. That's the greatest common factor. Now we recognize on the inside, whoops, right here and here, this piece is 2m to the power of 2, because 2m times 2m is 4m squared. This piece is 5 to the power of 2, because 5 times 5 is 25. So, because this is a difference of squares, it has a minus between them, we can separate it out then into 4 as our greatest common factor on the outside, times 2m plus 5, and times 2m minus 5. So this essentially has 3 different factors, one on the outside, one on the inside, and another one on the inside. These two multiplied together and then multiplied by 4 would make this piece. Looking at this one, we cannot take a greatest common factor out of these numbers. There's no number we can take out of everything. And because it has a plus in between and not a minus, that means we can't do greatest common factor, can't do difference of squares, so this one is not factorable. There will be some instances where your expression is not factorable. You just write not factorable for that one. We are going to skip this one. This is again just a difference of squares that we can take the greatest common factor of. We're going to go on to continuing to look just at the AC method factoring problems. In this expression, it is a trinomial. One term is the x squared, one term is minus 9xy, and one term is positive 8y squared. Because this is a trinomial, we have to try the AC method. So, A is 1, there's just a number 1 outside of this. C is this 8y squared, it's the last piece at the end. So 1 times 8y squared becomes 8y squared. As we break this down then, what factors will multiply to 8y squared? Well, that's 1y and 8y. These will multiply to that. Also, 2y and 4y. These will multiply to make that. We want to know which of these factors will add up then to negative 9y. Again, because this is positive, either these are both positive or they're both negative. Because we're looking for a negative 9y, we want these to both be negative. So, negative 1y and negative 8y have to be those factors. When we break it up then, this becomes x squared minus 1xy minus 8xy plus 8y squared. So this expression that had 3 terms now has 4 terms, which allows us to break it up into groups and factor by grouping. Now, looking at our first group, what can we take out of both of those 2 terms? We could take x out, and it would leave x minus 1y. Looking at our second group, what can we take out? We can take negative 8y out of both of these pieces, so it would leave x minus 1y. And notice in both cases, x minus y and x minus y are 1y. In one case it's times x, in one case it's times negative 8y. So we can break it apart into x minus y as one factor times the other factor, x minus 8y. If you were to FOIL these out, it would come out to this piece right here, our original expression. So we would say this then is our factored answer. We're going to skip these two and skip these two as well. We're going to jump back to this one. 5x squared plus 29xy minus 6y squared. Always check for greatest common factor. These don't have the same variables in them, so we can't take any variable out. 29 doesn't have the same factors as 6 and or 5. We can't take any numbers out of them, so we can't take a greatest common factor out of anything here. So we jump right into the AC method. A is 5, B is negative 6y squared, so AC is negative 30y squared. We break up all of the factors of negative 30y squared. When we do this, try to think of this as though it was positive first, and then we'll deal with making it negative. First off, we would have 1y and 30y. We could have 2y and 15y. We could have 3y and 10y. Or we could have 5y and 6y. These are the only sets of numbers that would multiply to make 30y squared. Now again, because this is negative, we want one of these to be negative and one of them to be positive, and we want them to add up to 29. Well, 5 and 6 are only 1 apart, so those won't add up to 29. 3 and 10 are 7 apart. They're not 29 apart. 2 and 15 are 13 apart, so those won't work. 1 and 30 are 29 apart, so these are the ones that we need to use. Because these are 29 apart from each other, it's going to have to be these two as a set. Now, because we want positive 29, that means we want the bigger number to be positive. So 30 is positive, 1 is negative, because negative 1 plus positive 30 would make positive 29. So these are the two factors that will break that piece into. When we do that, it makes 5x squared is still the same. This 29xy breaks into negative 1xy and positive 30xy. And it came from here and here. We just had to add the x with each of them. And this last piece, this minus 6y squared, stays the same. The first and the last piece will always stay the same. We're just breaking that middle piece up into two different things. Now that we've got it into 4 different pieces, we can split them up and factor by grouping. In our first group, 5x squared minus 1xy, we ask what can we take out of both of those? We can take an x out, and it leaves 5x minus y. In our second group, 30xy minus 6y squared, we ask what can we take out of both of those pieces? Well, that would be a 6y, and that would leave 5x minus y. Notice again, 5x minus y over here and 5x minus y over here. That means our first term is going to be 5x minus y, and it's going to be multiplied by the term x plus 6y. So again, this in the end will be our factored answer. If you take this thing times this thing, it would make this in total. Look at another example here. 8u squared plus 18uv plus 7v. We can't take a greatest common factor out of all of these. And there are 3 terms, so we have to do the AC method. A is 8, C is 7v, so AC would be 56v. Now if we look at all the factors, because this isn't v squared, one of them would have a v, the other one wouldn't. So it'd be like 1v and 56 alone. 1 and 56v. If we look through all of these possible factors, or all of these sets, none of these would add up to one single term. These can't combine because they are not like terms. Because these would not possibly combine into similar or like terms, we can simply say we cannot factor this. Because this didn't have the squared at the end of it with the v, it's not factorable. So let's review some of our problems here, some of our new concepts. If we have 5x squared plus 40xy plus 80y squared, again, this is a trinomial because there are 3 pieces, so we can't do a difference of squares. We'd have to look for the AC method. But we always look for greatest common factor first. And if we look at this, we can actually take out a 5 first before doing anything else. After we take 5 out, it leaves x squared plus 8xy plus 16y squared. So when we do our AC method, we'll actually be using these numbers instead of these numbers. So A would be 1, because it's a 1x squared. C would be 16y squared, so AC would be 16y squared. When we break it up and find the factors, it would be 1y and 16y, 2y and 8y, 4y and 4y. What we want is to add up to an 8, or an 8y should I say. So obviously in this case it's going to be the 4y and 4y. So like before, we split it up into 4 different pieces, still with the 5 on the outside. That was our greatest common factor from before. And we factor by group. 1 group, 2 groups. So what that looks like then, 5 on the outside still. This group has an x outside of it with x plus 4y. This group now has a 4y on the outside of it with an x plus 4y. In the end then, this becomes 5 times one factor, x plus 4y, and another factor, x plus 4y. You can always leave it like this, but also if you recognize x plus 4y and x plus 4y are the same thing, you can combine those into an x plus 4y squared. So we would call this 5 times the amount x plus 4y squared. So this would be our factored answer. Here we have 4 terms, 9x cubed plus 12x squared plus 36x plus 48. Because it is 4 terms, we can't do an AC method, we can only group. Before we group though, we always look for greatest common factor. And we can take a 3 out of each of these. So 3 comes on the outside, and it leaves this expression left over. On the inside then, we look at our 2 groups, and we factor those each individually. This one we can take an x squared out of, and it leaves 3x plus 4. This one we can take a 4 out of, and it leaves 3x plus 4. So our factor in the end has a 3 on the outside as the greatest common factor, 3x plus 4 as one factor, and x squared plus 4 as the other factor. So these 3 factors, 1, 2, and 3, are the fully factored answer of this expression. Here again we have another trinomial. 1, 2, 3 terms. We always check for the greatest common factor first. When we do that, it would become negative 2y squared on the outside, because that's what we can take out of each of these. And it leaves 3x squared y plus 10xy plus 6. Now again, this is not of the form the ax squared plus bx plus c, or this can have a y and this a y squared as well. Our extra variables are in the first and the second term. So this one will not fit the form of our AC method. So we cannot factor this any further. This right here is our fully factored answer. We cannot take anything else out of it. Looking at this one, we've got 2 terms. First thing we always look for is the greatest common factor, and we can take 10x out of each of these, and it leaves x minus 6y. On the inside there are 2 terms left, so we look for difference of squares. X is not a square number, and 6y is not a square number. So even though there's a minus here, there's not 2 squares being subtracted. So this would just be the end. This is our fully factored answer. And that'll be it for our factoring lesson.